Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial we're going to be using Lagrange multipliers to find the absolute maximum and the absolute minimum of our function. Now before we get started, make sure to subscribe to the channel for notifications on more math tutorials. Alright, now let's take a look at this example. Our example says use Lagrange multipliers to find the extreme values of f of xy equals 2x squared plus y squared, subject to the condition that x squared plus y squared equals 16. So we're being asked to find the extreme values, or in other words, the absolute minimum and the absolute maximum values, and we're going to use Lagrange multipliers to do this. Let's start off by reviewing the Lagrange multipliers formula. It says big f of xy equals little f of xy plus lambda times g of xy. And here, big f of xy represents our Lagrangian, little f of xy represents our function, lambda represents our Lagrange multiplier, and g of xy represents our condition or our constraint. So let's take inventory of what we're given. We're given a function of 2x squared plus y squared, and we're given a constraint of x squared plus y squared minus 16. Now let's plug these values into our Lagrange multipliers formula. We see our Lagrangian equals our function 2x squared plus y squared plus lambda times our constraint x squared plus y squared minus 16. So the next step is to take our Lagrangian and find the partial derivative with respect to x, which equals 4x plus lambda times 2x, and the partial derivative with respect to y, which equals 2y plus lambda times 2y. Now at this point, I'm going to take the partial derivative with respect to x, the partial derivative with respect to y, and g of xy, and I'm going to create a system of equations. Now that we have this system, we can solve it to generate our points. I'll start with the first equation in our system and solve the system to get one set of points. And then I'll start with the second equation in our system and solve the system to get another set of points. So we're going to solve this system twice, starting with two different equations. And that's because two different starting equations will result in two separate lambda values, and thus two separate sets of points. Once we get those points, we're going to plug them into the original function that we were given to get our absolute maximum and minimum values. So starting with our first equation, we'll factor out 2x. And then when we divide both sides by 2x, that leaves us with 2 plus lambda equals 0. And then we see that lambda equals negative 2. Now we're going to plug that lambda value into the second equation in our system. So we've got 2y plus negative 2 times 2y equals 0. Negative 2 times 2y is negative 4y equals 0. 2y plus negative 4y is negative 2y equals 0. So we see that y equals 0. Our next step is to plug y into the third equation in our system to get a value for x. That is x squared plus y squared, or 0 squared, minus 16 equals 0. That'll leave us with x squared minus 16 equals 0, and then x squared equals 16, and then x will equal plus or minus 4. So that just gave us 2 points, right? We've got point 40, and then we've got point negative 40. So that's our first set of points, and now let's start with the second equation and solve the system again. I'll start off by factoring out 2y. We'll divide both sides by 2y to leave us with 1 plus lambda equals 0, and then we see that lambda equals negative 1. Now we'll plug this value into the first equation in our system. That's 4x plus lambda, or negative 1, times 2x. Then we have 4x minus 2x equals 0. 4x minus 2x is 2x equals 0. So then we have x equals 0. And then we'll plug this x into the third equation in our system to solve for y. So that's x squared, or 0 squared, plus y squared minus 16 equals 0. That leaves us with y squared minus 16 equals 0. Y squared equals 16. And then y equals plus or minus 4. So we just got 2 more points. Those are 0, 4, and 0, negative 4. So now that we've got our points, we're going to plug these points into the original f of xy that we were given. At point 40, the function equals 32. At point negative 40, it equals 32. At point 04, it equals 16. And at point 0, negative 4, it also equals 16. So therefore, we see that the absolute minimum value is 16, and the absolute maximum value is 32. And there you have it. Using Lagrange multipliers, we've been able to find the absolute maximum and the absolute minimum values of our function. If this video was helpful for you, give it a thumbs up, like the video, subscribe to the channel for notifications on more math tutorials, and drop a comment down below. I'm Coach T, and thanks for watching The Numbers Game.